Okay, today we're going to talk about sine x, and we're going to look at the vertical transformations of it, vertical stretches, compressions, and then we're going to put it all together. So before we even deal with any of that, let's just remember what sine x looks like. Now, Desmos is awesome, right? We type stuff into Desmos all the time, and we get stuff. I typed in my curve. It doesn't look right, but that's because Desmos automatically is in what's called radians. And what we want are degrees. So you have to click on a degrees, and then you have to zoom out a whole bunch. So I'm just going to zoom out a whole bunch here. And yes, that definitely looks far more like our sine curve. So it goes forever one way, goes forever the other way, goes up and down, and there's our one cycle right there. Okay. So let me just come over here. Let's just draw a nice one cycle. Oops. So it goes up, comes down, comes up, and that's what one cycle looks like. Okay, so what else do we need to know? Well, our maximum, so our maximum here is at the value of 1. So that means my maximum here is at 1. Our minimum value is down at the bottom here. So let's see, minimum value is at -1. To get our amplitude, remember we have to take our maximum minus our minimum and divide it by 2. So in this case, that's 1 minus -1 divided by 2. 2 over 2, oh, it's just 1. So our amplitude is 1. And that makes sense. Our axis of equilibrium, let's just jump down to there for a second. Remember, that's our maximum plus our minimum divided by 2. 1 plus -1 over 2. Well, 1 plus -1 just gives me 0. So my axis of equilibrium is the x-axis. So it's at y equals 0. So that means my maximum is 1 off of it. There's my amplitude of 1. And my minimum is 1 off of it. So there's my amplitude of 1. Oh, okay. So that's just equal to 0. Our period, remember, is the length of one cycle. And our one cycle, well, it starts at 0 degrees and it ends at, where does it end? It ends right here. Oh, at 360. So the length of one cycle for our sine curve is 360 degrees. So that's good. Those are the main points that we're going to be playing around with. So this is at 91. This is at 0, 0. This is at 180, 0. This is at 270, -1, and 360, 0. So there's our 5 key points, and that's what we're going to play with. Okay, let's check out this example. So another thing that we've already looked at when we talked about these curves is we took the curve and we put it in context. So we talked about the Ferris wheel. Well, how about we've got Sarah who sits in an inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph below. And if you've ever been in a wave pool, you go up, down, up, down, up, down, up, down, up, down, up, down, right? So let's see. The period, remember, is the length of one cycle. So if I start the cycle here, then let's see. I go up, and I come down, and I go up, and then I start again at the middle line. So that is one cycle right there, from here to here. That's the length of one cycle. So that lasts for a whole 3 seconds. The maximum height in the pool, let's see, we're at a maximum height of plus 0.4, so 2.4. And I have a minimum height down here of 1.6. The equation of the axis, remember the axis is in the middle, okay? So the axis, remember we have to take our maximum plus our minimum and divide it by 2. So that gives me 2.4 plus 1.6, all divided by 2. So when you add those up and divide by 2, you should get an answer of 2. Oh, well, isn't that just right down the middle? Look at that, right down the middle. Oh, that's excellent. So it's that y equals 2. All right, let's see here. Amplitude. So remember the distance is the amplitude is from the axis of symmetry to either the maximum or the minimum. So these guys are our amplitudes right here. Amplitude, amplitude. The equation, so amplitude is max minus min divided by 2. So you get 2.4 minus 1.6 all divided by 2. So that gives you 0.8 over 2, 0.4. And is it 0.4? Oh yeah, totally. 2 minus 1.6, that's 0.4. There's 0.4. Okay, 0.4. Good. So that means she's bobbing up and down on waves that are 0.4 meters above and below where they would be if it's flat. So is this a sine function or a sinusoidal function? Definitely. Yes. Yes, it is. And why is that? Well, first off, it's periodic, right? Because it has that repeating motion. And then it's sinusoidal, which is another way to say sine. So these guys are the same thing. Sine and sinusoidal function, it's the same thing. Sinusoidal because it's got that curviness to it. Because it's that curve up and down motion. Okay, so sinusoidal curves, you've got your curvy, kind of like an upside down bowl, and then a right side up bowl. So it's a nice curvy motion. That's what makes it a sine curve. That's what makes it sinusoidal. Awesome. So now that we've recapped all the most important stuff that we've already talked about, let's just focus in here on this A in front of the sine. So A, just like in quadratics, just like in exponentials, it denotes a stretch or compression as well as a possible reflection. So if it's bigger than 1, it is vertically stretched by a factor of A. If it's between 0 and 1, so if it's a decimal or a fraction, it's compressed by whatever that value is. And if it's negative, remember then it's reflected in the x-axis. So it's going to go upside down. So let's look at this. We've got y equals 2 sine x. So the only thing that I've added into my sine x curve is this 2. So there's my A. So that means I have a vertical stretch by a factor of 2. So what does that mean? Let's remember. So that means I'm going to take all my y values and I'm going to times it by 2. I'm not changing my x's. They all stay the same. Okay, so my x's are all going to be 0, 90, 180, 270, and 360. So the cycle itself doesn't change, but my y value definitely will change. So let's see. We've got a y value of 0, so 0 times 2, oh, well, that's just 0. 1 times 2, well, that gives me 2. 0 times 2, oh, I love multiplying by 0. That's easy. Negative 1 times 2 gives me negative 2, and 0 times 2 gives me 0. So my new dot, so right here, my nice little dotty curve, that is my y equals sine x. Okay, so that's my parent function. That's my base curve. My new one, well, I'm still going to have the same dot here at the 0, and then it's going to be 92, 180, 0, 270, negative 2, 360, 0. And you just have to plot it for one curve. I mean, you can keep going if you want. That's fine. Where's my maximum? We're running about here. Sure, why not? And then back to 0. And then let's see if I can do this. Make it nice and curvy. 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 It's way harder than it looks. And I'm certainly not making it look easy. Curvy! So there's one cycle. Good. Now the whole thing, we have to state the domain and range for the whole curve. So sine, my domain is x is any real number, right? There's no restrictions on the angle you put in. Range, we do have a restriction. So your y is any real value, but it has to be between your minimum and maximum. And the equation of the axis, well, I didn't lift it up or down, so it's still at y equals 0, because I did not translate it up and down. Okay, let's try another one. Let's see, now I've got y equals -3 sine x. So again, the only one I have in there is an a. I don't have any c, and I don't have a d. So here I've got that a is a negative value. So that negative part means that it's a reflection in x-axis. And that 3 means I have a vertical stretch by factor of 3. Okay. So my x values, again, I haven't done anything to them, so they're going to stay the same. So it's still 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So all my x values stay the same. My y values, I'm going to take my y value and I'm going to times it by -3. Oh, times it by 0. Love it. 1 times -3. Oh, another easy one. Gotta love it. 0 times -3 is 0. -1 times -3. Watch those signs. Watch those signs. So that gives me a +3. And then 0 times -3. Well, that gives me a 0. Okay, here we go. 0. -3 comes down here. 0. And then it's a +3 goes to here. 0. And continues. -3, 0. Okay, let's see if I can't make this curvy. Oh boy, this one's going to be tricky. Let's see. Curvy, curvy. These are curvy, by the way. May not look like it, but they are. Hopefully you're doing a better job than I am. Curvy, curvy. Sure. So there, from 0 to 360 is 1 cycle. It's still 360 degrees. Good. All right. Domain. There's absolutely no restriction. So x is any real number. Range. You have to go from, so y is any real number, from the minimum, less than or equal to y, less than or equal to the maximum. And we did not translate it up and down, so the axis of symmetry is still straight down the middle there. Good. Whoops, I never finished my point. Sorry about that, guys. So that should have a 0. That should be 90 -3, 180 0, 273, and 360 0. Okay. So let's start putting things together. So what do we have? We know that y equals a sine x minus d plus c. So these are all the pieces that we've looked at. So a, we said, is our stretch or compression. Okay. Our d value, well, that's our horizontal translation. So that's where we go left or right, translation. And our c value, that's the one that moves us up and down. So that is our vertical translation. Translation. Good. All right. Let's try some questions here. We have a phase shift. Oh, they like to come up with all these new words for things. My goodness. Why do we have to have new words? I don't know. But we do. So phase shift, well, that's just another way to say a horizontal translation. And it has to do with the whole cycle and all the rest of it. So phase shift, so we know we have a horizontal translation, and we're going to go 25 degrees to the right. So it's going right 25 degrees. So that means inside my brackets, I'm going to have an x minus 25 degrees. Okay, so that's that first bit. Our vertical translation of 3 units up means I'm going to be plusing 3 on the outside. So that's my c value. And I've got this stretched by a factor of 3. So that means my a value is going to be equal to 3. So what does that mean my whole function is going to look like? Y equals stretched by 3 sine x minus 25. So that's my sideways to the right. And then up 3. Okay, let's try the next one. So let's see. I have a phase shift of 35 degrees to the left. So that means I'm going to have an x plus 35 degrees because I'm going to the left. Right? X's are opposite to what we think they should be. We have a vertical translation of 5 units down. So that means my C value is going to be down 5. I have a compression by a factor of 0.5. So that means my A value is going to be 0.5. And I have to reflect it in the x-axis. So that means it's going to be negative. Put it all together, and what do you got? Negative 0.5 sine bracket x plus 35 degrees minus 5. Whoa, are you ready for this? There's a good 90s line that says, are you ready for this song? Anyways, all right, let's see. We got y equals 1/2 sine x minus 120 plus 2. Lots of stuff going on in here. So our angles, well, we've kind of rewritten this. We're not dealing with that sign. Sorry about that. That should say x. And x, we've just been treating our degrees as our x values. So do we have a phase shift left or right? Yes, we do. We have a D value in here. So this is telling me I'm going right 120. So my x values have to go to the right 120. So that's 0 degrees. I have to go right 120. 90 plus 120 gives me, what's that, 210. 180 plus 120 gives me 300. 270 plus 120 gives me, what's that, 390. And 360 plus 120 gives me, what's that, 480. So these are my new x values. Okay. Now my y values, we've got a couple of actions that can be happening in here. So first off, let's deal with stretching and compressing. All right, so that's our x values taken care of. Let's look at our y values here. So the first thing we want to do definitely is stretch and compress. So yes, we do have a stretch and compression. That's our A value. So that's this 1/2 here. So that's our A value. So it's going to be y times 1/2. And if you don't like halves, that's fine. Just think of it as y times 0.5. Okay, sure. Our y value starts as 0, right? There's my y value. Starts as 0 times 0.5. Oh, well, anything times 0 is 0. 1 times 0.5, well, that's just 0.5. And 0 times 0.5, oh, well, that's just 0. Negative 1 times 0.5 just gives me negative 0.5. And last but not least, 0 times 0.5 gives me 0. Excellent. Then we're still dealing with our y values here. We have this piece out here. So this is our C value, remember, right? So that means we're going up 2. So that means I have to take my new y values, take the new y values, and we're going to plus 2. So I'm going to go 0 plus 2 gives me 0. 0.5 plus 2 gives me 2.5. 0 plus 2 gives me, oh my goodness, I can't add. 0 plus 2 is 2. Good job. Negative 0.5 plus 2 gives me 1.5. And last but not least, 0 plus 2 gives me 2. So my new point, the one I'm going to graph down below, I'm going to take my x values here. So it's going to be 120. And my new y value, which is 2. 210, 2.5, 300, 2, 390, 1.5, and 480, 2. So let's see what that looks like on our graph. So here's my original sine that's there as a reference. So our new dot is going to be at 122. So 122, going to go there. And then I've got a 210, 2.5, 302, 390, 1.5, and uh-oh, I'm off my grid, 482, let's show up over here somewhere. So that's at 480, give or take. So let's finish off our curve. So curvy, oh boy, curvy, curvy, curvy. That was a terrible curvy. Okay, I fixed my curve. It was pretty bad. So we've now got y equals 1/2 sine x minus 120 degrees plus 2. So that's what my curve looks like. That's the way it should be. It's shorter, it's pushed over, it's been pushed up. So my domain, let's get into these guys. So domain, remember there's no restrictions. So domain is always x is any real number. Range, so y is any real number. But I do have a restriction. I have a minimum value of 1.5. I can see it in my graph there, or my chart there, 1.5. Less than or equal to y, less than or equal to, where's my maximum? 2.5. Okay. Amplitude, well, we shrank our amplitude, and you can read it off of the graph. It only goes up and down by 0.5. So my amplitude is just 0.5. My phase shift, so that's how far I went over. So I went to the right 120, 120 degrees. My vertical shift, well, that was my up 2. So I went up 2. And the axis of the curve, so the axis of symmetry right down the center of it, well, where did it keep landing? 2, 2, 2. So that's at y equals 2. These guys should always be the same answer. So just in summary, let's all remember domain is always any real number. Range goes from my minimum, which I can read out of my dots, to my maximum, which I can also read out of my dots. My amplitude is how far off it is from the axis of equilibrium, but you can also read that straight out of your equation. My phase shift, so that's how far over it goes. That's my D value, so that's the 120 to the right. My vertical shift is how far up it goes, so that's my plus 2. In my equation, that's my plus 2, and that is also the equation of the axis of symmetry. And there you have it, folks. All done.